Saxon's Trig, lesson 75, is about combinations, and it begins on page 461. They start with a review of permutations, n things taken r at a time, and that formula said you will have the n factorial, and then you will do n minus r factorial, because that eliminates the extra pieces you don't have. So like if this had said, I have 10 items and I am pulling 7 of them, then if I were doing out my lines, I would have 7 lines to fill in. 2, 3, 4, 5, 6, 7. So 10, 9, 8, 7, 6, 5, 4. So once again, it's the 3 and down that I don't need because I don't have that many blanks to fill in. And where does that 3 come from? 10 minus 7. That's again why that formula works. So we did that in an earlier lesson. Now they're introducing combinations, and combinations throw out the order. So it's like when we did the circles, the order didn't matter. I had to designate a starting spot for one of them. So in combinations, which will again be an n items pulling r at a time, you need to tweak this formula so that you throw out that it has to be in a specific line order. So combination is basically saying, I don't care about the specific order of the lines. So there are certain embedded answers that are caring that it's starting in this spot, then this spot, then this spot, then this spot. It's basically in a combination saying, I want to pull 7 people, but I just want to throw them in a room. I don't care who goes in first, who goes in second, like it doesn't make them the president and then the vice president. The order does not matter. Okay, so it's going to keep the original formula as you saw with permutation, but to throw the order out, it is the number that you were choosing in a factorial. That throws the order out. So now you know the combination. So let's look at some examples to make this click. In how many ways can a committee of 5 students be selected from a group of 12 students? All right, so I have 12 students to choose from, and it says I'm choosing 5. Now I do stop to consider, is this combination or is this permutation? Since it's combination lesson, I just went ahead and put the C, but let's think our way through that. If I'm forming a committee of 5 people, does it matter which one I choose first to be on this committee? Nope, that makes it a combination. So if I take it straight to the formula, it's 12 factorial over 12 minus 5, 6. I had trouble there for a split second. And then the amount I'm choosing is the 5 factorial. So I can do that straight up on my calculator, or if I'm trying to write it out, I know it's going to be 12, 11, 10, 9, 8, 7, and then the 6 and on down I don't need, and then this one 5, 4, 3, 2, 1. I don't need to write the 1, but whatever. And then any reducing that I see, 2 goes into 8 4 times, 3 goes into 9 3 times, 4 and 4 cancel off, 5 goes into 10 twice. I've taken all the denominator down to 1. So 7 times 3 is 21, times 2, 42. Oh, then I can stop doing it in my head. Times 11, and then times 12. So either way, I end up having to use a calculator. But the answer should be, I'm trying to make, 792. Okay, example 2. There are 7 points located on a circle as shown. So you've got a circle and 1, 2, 3, 4, 5, 6, 7 spots. It doesn't matter which one was 1. They labeled them. This was 1, this was 7. It doesn't matter. All right, so there are 7 points located on a circle as shown. How many different triangles can be drawn using these points as the vertices? So I'm drawing triangles. So using those would create one triangle. So I'm going to need, I basically have 7 spots, and it's circular, so I know that the order does not matter, so it is definitely a combination, and it requires me to fill 3 spots for the 3 vertices to make the triangle. And then I know because it was combination, I need to do 7 minus the 3, which is 4 factorial. So here is ultimately what I'm doing. So on the calculator, 7 factorial divided by 4 factorial and 3 factorial ends up giving you 35, or if you hand write it out, 7 times 6 times 5, don't need the 4 and below, 3, 2, don't need the 1, 3 and 2 make 6. So basically 7 times 5 is 35. So that one I can do that way by jotting it out, not using the calculator, but whatever. Example 3. How many different 5-card hands can be dealt from a deck that contains 52 cards? I have 52 things to choose from. I'm choosing 5. Is it combination or is it permutation? 5-card hands. All right, it's a hand. Does it matter which card comes first in the hand? No, combination then. So it's going to be 52 factorial divided by 52 minus 5, which is 47, so I thought. And then the 5 factorial, throwing the order out. And that is, yeah, that one I definitely would do on a calculator. 598,960. Yikes, that is a lot of different hand combinations. Yep, just making sure I had written all that. That is all of lesson 75.